Hi students, I want to give you a good example of using our distributive property to simplify an expression. I want to walk through number 10 on your study guide. I know I did this in class, but I want you to be able to look through and really focus on the points that you may be struggling with. So when I'm looking at this problem, number 10, it says 7 minus 2 being multiplied in parentheses 9x plus 6. I need to ask myself first, in order of operations, am I going to subtract first or am I going to multiply? Because it says 7 minus 2, that would make it easier, then I don't have to worry about that 7 out front, or do I multiply and distribute that negative 2 in? An order of operations says that I always multiply first. But first, before we even do that, I want to point out what the terms are in this equation. I have a positive 7, a negative 2, and then inside my parentheses, I have a 9x and a positive 6. Our numbers and our variables own the sign that is in front of them. So that 2 is not just a 2, it is a negative 2. That can be flipped between subtraction and negative. It would be the same thing. So when I look at this, I have this 7 out front. For now, we're just going to leave that 7 out front, and it's going to stay 7. Then we are going to distribute that negative 2 to each of my terms inside my parentheses. The negative 2 is our card dealer being multiplied to all of the players in our card game, so it has to be done equally. So a negative 2 multiplied by a positive 9x gives me a negative 18x, and I'm going to write it just like that, keeping that negative sign with there. Then I'm going to multiply that negative 2 out to the positive 6. Negative 2 multiplied by a positive 6 is a negative 12. I'm going to write that negative with it. So now I have a simplified version of the original expression of 7 minus 18n minus 12. If we double check now, if I would have looked at my first one and had 7 minus 2 times 9, x is still that 18x, that stays the same. We need to remember that that 2 is negative because of this second portion. Otherwise, we will have the wrong sign in front of our 12. Now, when we're looking at our expression, I need to ask myself, can I simplify it any further? Do I have any that are like terms? And to know if they are like terms, they would either have to have no variable at all and share that in common, or they need to have the exact same variable to the same exponent, to the same power. So I see that I have a positive 7 and a negative 12. Neither of them have exponents, so they are going to be like terms. I can use my commutative property to change the order and then have it as 7 minus 12, because that sign with the 12 stays with it. So it's 7 minus 12 minus 18n. The sign with that 18n stays with it here. So it's a negative 18n. Now I can look at my expression and see that I have 7 minus 12. I know that 7 minus 12, they're like terms because neither of them have variables, is going to be a negative 5. Then I'm going to bring down what I have left over, which is a negative 18n, or subtract 18n, and this is my answer. I cannot simplify it any further because negative 5 does not have a variable, and negative 18n does have a variable. They are not the same. It's like we have negative 5 M&Ms and negative 18n, that means boxes. So we can't combine the M&Ms and boxes into the same thing. So we are finished. That is the simplified form. Going on with those like terms, let's look at number 11 on your study guide. We have the problem 6a plus 2b plus 5a minus 7, and we need to point out each piece of that expression. So if I'm looking at them, I need to find the coefficients. The coefficients are the numbers directly in front of the variable, but they do not include the variable. So I want to find my variables, and 6 is in front of that A. So that is one of my coefficients. It's a positive 6, so it's going to stay a positive 6. I also see a B here with a 2 in front of it, so just the number is my coefficient, so it's a positive 2. I also see a 5A. It's just the number in front of it, so it's just a positive 5 as my coefficient. I do not have a variable in my term with the negative 7, so it is not a coefficient. It needs to have that variable there to make it a coefficient, but the coefficient, again, is just the number in front of the variable. I'm going to jump down to our constants. Constants are the numbers that do not have any variable with them. It's just the number. But again, for all of these numbers, whether it's a coefficient, like term, or a constant, it owns the sign in front of it. So if there's a positive or an addition sign in front of the number, it's a positive. If there is a negative or a subtraction sign in front of the number, it is a negative number. So if I look at my constant, it can't have any variable. I only see one number that does not have a variable up here, and that is my negative 7. The sign stays with the 7, so it's a negative 7 for my constant. Looking at our like terms, we need to find the full terms that have the same variable to the same power. Our terms are separated by our addition and subtraction signs. So one of my terms is 6a, another term is 2b, another term is 5a, another term is the negative 7. But I need to find them that are like terms. So they have to be the same they have to have the same variable to the same power or no variable at all. I only have one number without a variable, so it wouldn't have a like term. It doesn't match with anything else. So I'm going to look at my numbers with the variables. I see I have a 6a and also a 5a. They both have an a to the first power. So my like terms then would be a positive 6a because it's a positive 6, and a positive 5a because it's a positive 5. For our like terms, we have to show the variable that makes them like terms and the coefficient that is with them. So this is a good review for you to look at and study for your Chapter 2 test. That is tomorrow.